I'm going to go in front of you. Have you ever done homework steps? Don't worry. Have you ever done homework steps?
I've opened my book outside of the class. Since opened his book in a long time. I don't open my book outside of the class ever.
Okay, so yesterday, intuitively Milad said, okay, let's say you have n trials. Let's say the probability for success for any trial is P, which is a constant. Let's say, for example, it's 30%. So he imagines, so he's kind of like, think of every trial as an apple. You do your first trial, 30% of it is successful. You go to your next trial, 30% of it is successful. So for each trial, you end up with 0.30 of your apple or your trial, plus 30% of your next trial, plus ... plus 30% of your last trial. You have a total of n trials equals 0.30 n, right? Which equals Pn, which equals NP. So that's an intuitive way of doing it. We were going to prove it formally, and we did it. Why did we do it? We did it for the hell of it, but it's important. It's useful. So let's do it. Well, we tried doing it. We started, right? I put it up there, and then I got stuck. Then you got stuck, and then your job was to go and see if you could unstick it.
Did you figure it last time?
Yeah.
You did?
Okay, so let's try. No,
I got it.
it's gone. Oh! Okay, so we have to start with a definition of expected. We're going to start the exact same way we started yesterday. Expected value is really just what did we say expected value was? It's just
An individual.
come on, man.
I wasn't here.
Expected value was another way of defining average, right? What's the definition between the equation for, this was one way of defining average, for example, right? But expected value doesn't define it that way. What was the difference again?
If you have two same numbers, and then you just add them once.
Yeah, so for expected value, your domain only has unique possible values for the random variable x, and if it exists more than once, you address that by the frequency or probability. So by definition, your expected value equation is going to be the sum of from I equals 1 to n of, what do we have? xi, p, xi, right? Where this is the probability associated with each of the possible values of the random variable x. Yeah?
So you don't divide it by n?
No, because the n is in here. Because let's say there were 10 data points. You know what I mean? Every one of those probabilities has the n in its denominator. If you work it out again with the math, you could get that form, the other form. So specifically, we have E binomial expected value is going to equal, I is equal to 1 to the n xi of binomial. Now, what did we say the equation was for the probability distribution of a binomial? It was n, choose x, right? Times p to the
x.
q, or I could write it as 1 minus p to the...
Yeah.
Okay, now here's the only thing that we should change. This is an n, right? N is for the number of trials. But in this case, what does the n refer to? In this equation, the n refers to the total number of unique values for the discrete variable, right?
Yep.
In this particular case, n refers to what? The number of trials?
Yeah.
If you have 4 trials, an x refers to the number of successes, right? If you have 4 trials, what are the possible values of success? You can have no successes out of 4. You can have 1, 2, 3, 4, right?
5.
But, so how many different values of x are there? 5. And what was the number of trials, n? What was the size of it in this example? 4. So the total number of possible values of xi exceed the number of trials by 1. So really, I could write this like this. Let's say I could make this m. I could make this m. But then I should realize that if I change it from m, it's really n plus 1. You see what I mean by n plus 1?
Yes.
I could call that m, let's say. But if I want to use this equation and for those n's to mean the same thing, they're n plus 1. Why? Because what's your first value? What's x1 going to be? 0. Your next value is 1.
And it goes to n. So
exactly. So you need a thought, right? Exactly. Beautiful. Beautiful.
Beautiful.
So next we have, and you guys will correct me if I'm wrong anywhere along the way, because it's very easy for me to make a mistake here. I only looked this through once. So we have xi, we have probability of xi. Well, it's that, right? It's n choose x times p to the x times 1 minus p to the n minus x. Agreed so far? Does that look right so far?
It looks right.
Okay.
Where does the n plus 1 come from?
Okay, n plus, okay, so the thing is, you go from, you should have 0 successes, 1 success, 2 success, 3, and 4, okay? So you have 5.
Okay, that's what I was explaining.
0, 1, 2,
I'll explain it
3, 4,
again.
you have 5.
No, it's not always
Start
equal.
counting from 1, it's 1, 2, 3, 4, 5, and it's 1.
Look, in general, when you see this equation, you see an n on it, right? But now I'm trying to apply this equation to this probability distribution, which also uses the letter n. Okay? So I'm not going to use the letter. So I need to figure out so I decide, okay, well if that uses the letter n, then I'll use the letter m for this one. And then I can decide if they're the same or not. Well, what do they mean? When you go through this, this means x1 px1 plus x2 px2 plus x3 px3 plus dot dot dot. What does x represent in expected value? The total number of unique values, right? The domain, right? Total number of unique possible values of x. Total number of unique values of x. Well, what does n refer to? Sorry. Yeah, and in the context of a binomial, what are the unique values of x? They're the total number of possible successes, which start from 0 successes, 1 success, 2, all the way up to n. So that's a total of how many values of your domain? N plus 1. Okay, which equals n plus 1 possibilities. I.e. from 0 successes to n successes. And this is for a binomial distribution specifically for binomial. So then that means that how many of these am I going to have? I'm going to go through this n plus 1 times. So I just change it from m to n plus 1 so that I can just use one variable, okay? You're going to see though, if I recall correctly, this n plus 1 is going to go back to an n in a second. Based on something we did yesterday, yeah.
Wouldn't it be easier to just put I equals 0 on n? Because I think this is confusing everything. And when we're rewriting it, when we say x1, you have 0 successes, and then you get confused when you want to write it. So wouldn't we just? Let me
try. It's not a hard proof, but it's not the simplest. So let me at least try and go with the way I remember it.
Okay.
Okay, and then if it falls apart, then we can go with whatever you want. I'm totally cool with that. Because I think your issue is gonna be resolved very quickly. Hang on. So what do we have? I'm gonna write it like this. I guess technically this is an xi too, isn't it? That x is an xi, isn't it? Yeah. So we have nx1. Let's write it this way. I'm gonna write it like this: x1 p x1 1 minus p minus x1 no. Why? Why are you so lost? Your first one is going to be x. Remember, you start with I is 1. So x1, n choose 1, px1, 1 minus n, and so on and so forth. And what's the last one going to be?
N plus 1.
Right?
Yeah, plus 1. Oh my god.
But I shouldn't write it in that order. I should keep the order consistent probably, right?
Probably.
So this is going to be xn plus 1, right?
Yeah. P to the power of
P to the power of
xn plus 1.
n.
No, xn plus 1.
Yeah. Okay.
It's going to be 1 minus p to the power of -1.
Hang on. You're staring at me here. Can I
Oh, no, nothing. Sorry, no. N minus 6.
You always have
Okay, check that over me, lad. See what you think so far.
That's correct.
Okay. Now, what is x1? x1 corresponds, x1 equals what?
0 successes.
0, right? Because x corresponds to the, for a binomial distribution, x corresponds to the total number of successes. Total number of possible successes from 0 to n, right? So what happens to this term? So then what happens to this whole term? It's gone, right? Agreed?
Yeah.
Which means how many terms do we have left? We're left with we only have n terms left, right? Okay. So now,
No, not the. Wow, why did you hear that?
let me just take a look at mine. I don't care. Okay, so I feel like I should switch to J now, but
Oh wow.
Oh
Getting
my.
complicated.
Great God.
just give me a sec.
Should you will spend 1 period for this?
Yeah, I'm right. Well, that's what I did. Okay, so what I'm going to do now is I'm going to call this J equals 1 to n. Why do you think, okay, why do you think I'm changing it to J? Why do you think I'm changing it to J?
Let me think about
No idea.
Because the first term now that I'm dealing with, right, is going to be what,
Oh, okay.
when we're talking about, we're in the I world, now the first term that's left is x2.
So you basically did what I said, but later.
Yeah, exactly. So now we're in the J world, that's going to be my first term. And we're going to still go up to n. And what do we have? We still have n choose x, right?
XJ.
Sorry?
XJ.
And actually we can make it n choose j, can't we?
XJ is J, yeah.
Sure. But the first term is 2.
Yeah, that's why you changed it.
Yeah, yeah. So yeah.
Why
okay,
don't you-
sorry.
J
I will write it just like that. So my first term is going to be xj. Okay. But think about it.
XJ is J.
Yeah, that's the nice thing. What is xj?
J.
You can write it as j, right? Because your first value, when it's 1, when what does x1 correspond to now? It's supposed to correspond to this, which was how many successes?
1 success.
1 success. So you can just replace xj with j. Because you want it to start at 1 success, right? You want this thing to start at 1 success. Make sense? So for j is 1 success, which was x2. Because x2 is 1 success, then x3 was, and so on and so forth.
So wouldn't it be easy to do?
Can I finish
Because
it?
I feel like people.
Can you let me finish?
Mr. Miller, Mr. IBM.
So if you have nx2, now you can just write this as n choose j, right?
Right.
Okay? And now you have p to the j, correct? Times 1 minus p to the n minus j. Let me just check my note here.
So you didn't keep the order?
Yeah, I'm sorry I didn't keep the order, but look it over. What do you guys think so far?
Is that the answer?
No, are you crazy? We're getting this. We're getting there. So we'll say here, note,
J is
now xj simply equals j.
So you can say J is I minus 1.
Yeah.
Less confusion.
Okay, so the engine, do you follow this so far? Good. Now, let's write out the factorial thing. Well, actually, I'll do it up here. The combinations thing. Let's write out the combinations thing. So let's go over here. Okay? And you can spin that thing, the engine. I want you now, on your own paper, to expand. You know what this looks like. I want you to expand this, please. The n choose j. And I want you to do it. I want you to expand that, please. You know how to do it.
Isn't that supposed to be factorial?
Yeah. And I want you to do it because what I want you to do is I want you, who's outside? Let's go. And I want you to do it because I want you to get rid of that j.
That's easy.
Mm-hmm. It is.
Just erase. No, J factorial.
Yes.
Times J minus 1.
Oh my god.
Oh my goodness.
Okay. Do you guys see what we've done here? Do you guys understand that n choose j? Remember the definitions of combinations? It's n factorial divided by n minus j factorial over j factorial.
I
Right?
see what you did there, sir.
Okay, you see that? Now, Christian, 5 minutes, you get on the attendance. Okay, so we better finish this in 5 minutes. No, not yet. We'll finish first. So I expand, so this right here is just n choose j. And then once I did that, I got rid of that j by turning that j factorial to j times j minus 1 factorial, right? Remember I taught you that if you have 8 factorial, that's the same as 8 times 7 factorial? Why did I do that? Because by doing that, I created a j here, which could get rid of that j over there. Okay? It'll make sense. So, now, if we clean this thing up, where are we at? We are at, if I just write where we're at, I'll write it like this. Or do I need to write that stage? No, I'm not going to rewrite it. So you can see that this is gone. Okay, the j is gone. Now here comes a move that I would never have thought of making. Okay? And it's cheating. Because we know that the answer has to be NP, right? So what I want to do is I want to see if we can generate an N and a P in here. Now one of the rules of sigma notation I taught you is that when you have a constant, you can take it out of the sigma, right? So how can I generate an N from N factorial? Use that same trick, right? Let's generate an N. How do I get an N out of this? I turn it into?
N multiplied by N minus 1 factorial.
Excellent. Okay. And How can I generate a P out of this?
I don't think you can.
Sure you can.
You can P.
Turn it into P times.
Pj minus.
Right. Because if you keep the base and add the exponents, what's the implied exponent here? 1, keep the base, add the exponents. 1 plus j minus 1 gives you back j minus 1. So you can do that. And then you have that. Now you've generated a P and you've generated an N.
What a cheater.
Agreed? Now N and P are constants, right? In a binomial, well, N is the total number of trials, which is constant. P is the probability of success from trial to trial, which you agree does not change. That's a constant. So the N and the P can come out over here, right?
Yes.
You can take them out of the sigma, which I've already taught.
Smart.
Now, why is it smart? You don't know if it's smart yet.
No, it's cheating.
Okay, that's so stupid. But anyways, I think it's smart.
Why is it smart?
Because you put the constant outside.
But why is it smart to take a constant outside?
Because you know the final answer and then you source it.
Exactly. So if this is the final answer, what do we have to prove that everything else is equal to?
Yeah.
1.
1.
Smart.
All we have to do is prove that the rest is equal to 1.
What is it?
Well, it better be. Otherwise, we're in big trouble here. Well,
We disproved.
So don't worry, you can screw yourself.
no, we wouldn't have disproved. Oh, gosh. Please check to make sure that I'm copying this stuff down correctly.
Can drop English.
Do I have it right so far?
Yes, you do.
Okay.
So do you want me to actually do this?
You probably want to see this finish, right? So we'll wait a couple seconds. Okay. So,
So I think we missed an N
where? Show me.
on the top.
Please tell me where.
It's N and P and get outside. So
And
That's right.
N times brackets, N minus 1.
N minus 1 is there. N minus
Yeah, but
1.
where's
you
N?
missed out the N.
The N is here.
N is took it out.
Oh, yeah.
Constants, right?
Come on, stop me.
We did that. I taught you that, right? We talked about the rules of sigma notation. Okay, now
Don't eat your own clothes.
what we're gonna do,
It's like eating the...
we're gonna let these things be letters because what's gonna. So now all we have to do is prove that this.
Equals to 1.
Yeah.
But how can you prove
Well,
it?
we're gonna do that.
That's why in the class.
So what I'm going to do now is I'm going to call this, I'm going to define this as A, and I'm going to define this as B. And if you work it through,
Yeah, I see what you...
if this is A and this is B, what is N minus J?
A minus B.
Yeah, because N minus, you can see that N minus J is equal to N minus 1, which is A, minus J minus 1, which is B, which gives you N minus 1 minus J plus 1, okay, which equals N minus J. So then I can say, this is equal to A minus B. So then I can rewrite this whole thing as equals NP.
A choose B.
Now I'm going to leave the top and the bottom out of it for a second. I have A factorial over A minus B factorial. I have a B factorial. I have a P to the, what is J minus 1? B. I have a 1 minus P to the A minus B. Now, we're very close because, and I'll fill this in last. What does this look like? Well, this to me looks a hell of a lot like A choose B, doesn't it? Does that look like A choose B?
Yeah, it does.
It does, right? And what is the equation for a binomial probability distribution? B binomial is whatever, n choose x, p to the x, 1 minus p to the n minus x, right? This to me looks like the equation equation for a binomial distribution with how many trials? No, 8 trials. 8 trials and how many successes?
B.
And B successes.
Also, there were.
Now, any probability distribution, when you add up all of the values in that probability distribution, right? What does it have to add up to?
Some to 1.
100% or 1. The only thing we have to make sure is that this goes from B equals 0 successes up to A. We have to check that. So, let's see if that happens. Well, when J is equal to 1, what does that mean?
That means B.
When J is equal to 1, what is J equal to? By definition here, from over here, we have J minus 1
equals B.
equals B, right? Therefore, J, well actually, what am I saying? If J minus 1 is equal to B, when J is 1, what does B equal?
0.
Right?
Yeah.
When J is equal to, sorry, if B equals J minus 1, when J is 1, B is 1 minus 1, which is 0. So you can replace the bottom limit here of your sigma with B equals 0, because when J equals 1, B equals 0, right? And then the question is, well, what is the top limit in terms of B? Well, we're going up to N, right?
A plus 1.
Sorry? Yeah?
A plus 1.
You said A plus 1?
Yeah.
So the top over here is N, right? And
N is A plus 1.
N
N minus 1 is 8.
A is defined as N minus 1, right?
Yeah.
A is defined as N minus 1.
N is A plus 1.
So N is the same thing as A plus 1.
How does that?
It doesn't. Maybe it does.
It's supposed to go from 0 to A.
Hang on.
Oh.
A is equal to, if A is equal to N minus 1, this corresponded to J equaling N, correct?
Yes.
This means that J equals N. So
That doesn't matter.
B is equal to J minus 1
Equals to N minus 1.
equals to N minus 1, right?
Which is equal to A.
So why is J equals to N? J will be equal to N at the end.
Yeah, that's the point.
Hang on.
J will go to.
Just give me a
that
second.
point. That'll make sense.
B is equal to J minus 1, correct?
Can I go to my desk?
Yes. B is equal to J minus 1. This top value means J starts at 1 and J goes to N, right? So if B is equal to J minus 1, when you replace J with N, you get B is equal to N minus 1. So you can say this is B is equal to N minus 1. But what is N minus 1 defined as?
A.
Right? But N minus 1 by definition is A. Therefore, you can also talk about the top limit as B stopping at a value of
A.
Now, isn't that what we said? When you go from 0 successes up to a total of A successes?
Yeah, but I have a question.
So therefore, you have that and that.
How do you explain when you said N minus 1 is A?
I just made it up. You can call it chew if you want. You can call it T.
I know, but that's the same A. So if N minus 1 is A, then A is N, then N is A plus 1.
I'm lost. I don't know what you're saying.
You said
So
that.
you're saying you agree with this, right? You agree with this. You agree with changing this to this.
Yeah.
So then my top limit here is J is equal to N. Agreed?
Yeah, I agree with that. I agree with that logic. But there's another thing. You said N minus 1 is A,
Yeah.
right? So that means N is A plus 1.
No way. Yeah. It's fine. It's fine. Because look, you're saying there's nothing wrong here. Okay, a is equal to n minus 1, therefore n is equal to a plus 1, right? That means j is going up to a plus 1, right?
A plus 1.
But that, no, j goes to a plus 1. But what does b go to?
Okay, got it.
Got it? Yeah, you're right. This could be rewritten as a plus 1. But I need to know what the top value is for in terms of b, right? You can turn that into an a plus 1 if you want to. But what does that mean in terms of where b is going? Right? So no, there's nothing wrong with this whatsoever. Yeah, b is equal to n minus 1. So that works out. Okay? So this is what's called a formal proof, right? And it kind of gives you an idea as to one of the reasons why expected value is defined, okay, as a method of defining average. And of course, the other two, like there was an expected value for geometric, which was q over p, which was an infinite sum, right? Which you're not going to have to do. You have to use some calculus for that. And hypergeometric, we're not doing either. But I thought I'd show you one of them, okay? I just thought I'd show you one of them at any rate.
Are you going to ask for us to prove it in the exam?
Are you crazy?
Not?
So take the whole.
That would be like a great bonus question.
No, Gallo is not doing this with his class.
What about a bonus question?
We're not allowed to give bonus.
Oh wow, this is strange.
The only other thing, okay, so how many of you guys followed it? One?
Can I say I
Little
follow
bit.
70%?
You?
Followed up to 80% and then.
Krish?
75%.
Fell apart in some spots?
So what did she
Jay?
explain it again?
Are you out of your mind?
There are only 3 people got it.
Dude, I can't go through the whole damn thing again.
Well, actually, it's not going to be on the test. So.
I have a question here. Hang on, go ahead. What do you not get? Okay, I'm gonna let this be a triple line, right? By definition, I'm gonna call this A. We could have called it T. You could have called it anything you want. I'm gonna let j minus 1 be B. Now, let's figure out what n minus j is in terms of A and B. Do you agree that n minus j is the same thing as n minus 1 minus j minus 1? Because you would see, look, I've shown you, n minus 1 minus j minus 1 is A minus B. And what does it work out to being? It works out to being n minus j, right? So n minus j is the same thing as a minus b. So I can replace this with an a, I can replace this thing with an a minus b, and I can replace this with a b. Agreed? There's a j minus 1. What do we define j minus 1 as? B. Replace this with a b. What do we define n minus j as? Well, n minus j works out to being a minus b. Agreed? Done. This is all done. And this is the same thing as this choose this. Agreed? Now, there's a sum here. Oh, this is clearly a binomial distribution, right? Where you have a total of a trials anywhere where you have b successes. From 0 up to a. Agreed? So if this actually could be shown to go from b equals 0 up to a, then that corresponds to the addition of all of the possible outcomes in a distribution. And what is the sum of all the outcomes in any probability distribution? 100% or 1. So all we have to do is we have to show that this summation really, which goes from j equals 1 to j equals n, really goes from b equals 0 up to a. b equals 0 up to b equals a. Where b is your number of successes. In a binomial distribution you have 0 successes up to a maximum of, in our case, a successes, right? So, let's see, when j equals 1, what the hell does that mean? Well, in terms of b, because I want to do it in terms of b. Well, by definition, b is equal to j minus 1, by definition, right? So what happens when j equals 1? Replace this with a 1. What do you get?
0.
So when you say j equals 1, another way of saying that is b equals 0. So I replace j equals 1 with b equals 0. Now, let's see if we can figure out what j equals n means in terms of b. Okay? So what do we have? Well, one thing we can do is we can write down
that n b is j minus 1.
b is j minus 1, again. b is equal to j minus 1
So
by
b is
definition.
equal to- b is n minus 1.
Did we put it up there?
No.
Nice socks.
I have major few problems. I literally have to teach that right.
Okay.
So B equals n minus 1.
Okay, so again, you can go back to the definition of B being defined as j minus 1. This corresponds to j equaling n. So let's replace j with n. What do you get? You get n minus 1. Agreed? So yeah, you could say that this goes from b equals 0 to b is equal to n minus 1. But by definition, what was n minus 1?
B.
No?
A.
A. I can't hear you. So, it's the same thing as going from b equals 0 up to b equals a. Now you got it, right? You have your first case where no successes are right, plus 1 success, plus 2 successes, plus 3 successes, plus dot, 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 up to the maximum number of successes. The sum of that has to be 1.
Let's have a round of applause for Mrs. Stang.
Better? Okay, now let me show you one last thing and then you guys have lots of questions to try. Okay.
So that was beautiful.
Cool, eh? It's not my proof.
Whose proof was it? Google?
Oh yeah, I went online and I was like, I found one and it was so bloody slow. And the kids, the grade 9s were watching me. I was screaming at the computer because the guy was taking forever.
Oh, it was a YouTube video.
Yeah, it was a YouTube video.
How long is it? 30 minutes?
Wait, this was started in grade 9?
No, I was in the grade 9 class and I just went online and I was just...
Yeah,
Oh.
So, because really there are only 2 tricks in it, right? Like there are only 2 tricks. The real trick is the NP trick, moving the NP out, and the definitional part. We got the other trick yesterday of the first thing going to 0, right? We did that. We got that part. We were like the first one is 0, but I wouldn't have thought of that. Never. Okay, so the last thing I wanted to show you.
Yes.
If this like 100 years ago, we would never ever get to that.
Sure, so you just show something random to your innocent grade 9 kids.
What? No, I didn't show grade 9s this.
No, he was doing it.
I
in
used the
grade 9.
computer in the room.
He doesn't do anything in grade 9 class.
Are you kidding? We do tons of stuff. It's a grade 9 gifted class. We do all kinds of stuff.
MDM.
Okay, now, I just want to show you one last thing, and I'm just curious. Revisit.
What did I do? 2 plus 2 is 4. That's grade 9.
Doctor. Nurse.
That was hypergeometric, right? How many doctors were there?
5.
6.
How many nurses were there?
5.
And we need...
4.
Did we do this question?
We did. But I just wanted to show it to you one other way, because I think it might be nice to compare against binomial. So, let's see if you remember. Who remembers how to use that formula? If you have no nurses, you're only taking what?
0.
Doctors. So you can say if you want no nurses, 4 doctors, all over,
11, 4.
right? If you're gonna, this way would be
5 choose 1.
5, 1,
6 choose 3.
all over the 1. 5, 2, 6, 2, 5, 3, 6, 1, 2.
now. Could it be done? Could it be done another way?
Sure.
Go.
Probably, yeah.
If you were to go with all, no nurses, that means all doctors, right? How many doctors do you have?
6.
But sir, we should make which event to be success. We should define it at the first time.
We did.
You define.
In this particular case, this particular problem involves figuring out the total number of the probability of getting any number of nurses on the committee from 0 to 4. So if you want, you can define success as getting a nurse on the committee.
Okay.
Okay?
Is it that tight?
So if you have no nurses on the committee,
How's that 6 over 11?
how many doctors are there?
6.
Okay.
But you only need 1. Okay.
Anybody agree with that?
Yeah. Okay. That's the same thing as 6 choose 4.
Anybody agree with that?
Over 11 choose 4.
Yeah, I guess.
Yeah.
Notice, you can call this if you want. You can call this, well, in this case, this is, you can think of this as 1 minus p, right? Because in this case, you have 0 successes, so it's all failure. In binomial, does p or do p or 1 minus p change from trial to trial? No. But in this case, does the probability of success and failure change from trial to trial?
Yeah.
They do. And does this work out to being the same thing? What is 6 choose 4? It's 6 factorial over 2 factorial, 4 factorial, divided by 11 choose 4, which is 11 factorial, over 7 factorial, 4 factorial. What does that simplify to?
6 over 11 multiplied by 5 over 10 multiplied by 4 over 9.
That was very fast, what you just said. It was way too fast for me.
No, the 4 factorial is low.
The 4 factorials go, right?
And then 7 factorial over 11 factorial is 1 over 11, 10, 9, 8.
Okay. Let's see what we get here. We have 6, 5, 4, 3.
So it's
6, 5, 4, 3 is the same thing as this.
6 factorial over 2 factors.
And what is 7 factorial over 11 factorial?
1 over 11, 10, 9, 8.
Yep.
Let's keep calling.
So the answer is the same. And of course, this, what's interesting here, is this is an x, 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 x. Is this with replacement or without replacement?
What do you mean?
Are these x's with replacement or without replacement?
What do you mean?
Say it. Without replacement. In other words, once you choose a doctor, for the next stage, can you choose a doctor again?
No.
No. So you can call this, I even like to call these, I'll call these y's, and I'll call these x's. So, is order being counted for the numerator and the denominator?
No.
Come on, I've been looking to teaching you this course for months. If they're all the same variable?
Yeah.
Yes. Order is being counted.
But it
Oh,
doesn't
But what's interesting, yeah, but it doesn't
Both
matter.
of them.
And why doesn't it matter?
Both of them are counted, so it's the
It's
same.
offsets.
Why do they offset?
Because it's to both.
Because it's without replacement.
Yeah.
So
So
every possible thing in the chain up there will have a unique string of 4. Unique string of 4. And everything here will have a unique string of 4. So you get that
So you
offset.
don't even need to think about the order.
No, you don't. And that's why you see it in this formula. Right?
That's why the left one is easier.
That's why the left one is easier, exactly. But the nice thing about writing it this way, and you guys can figure out the rest if you like. The nice thing about writing it this way is just, it looks more like the binomial one, right? The binomial one has, multiple p's and multiple q's. Because if you had a binomial one, remember the 4 rolls for the die? What was 0 for the binomial? It was 5 out of 6 times 5 out of 6 times 5 out of 6 times 5 out of 6, right? Fail on your first roll, second roll, third roll, fourth roll, right? All of these are 1 minus p's. But here, this is constant. Here, the 1 minus p, if you will, is not a constant. So you see the difference between binomial and
So it is
hypergeometric.
It's dependent.
Exactly. These are dependent trials. Later trial, the probability associated with later trials depend on the outcomes of previous trials. In binomial, no. And it's harder for you to make that comparison when you see it like this. See what I mean? So yes, this is a nice way of doing it. The book does this, I do this. But it's nice to also see it this way because it makes a nice comparison to this. You see the difference. Look at that denominator. It's flat. Look at that numerator. It's flat. Look at that numerator and denominator. They're not.
So did you think of that?
Yes. That's me. Cool, eh? Book doesn't show that.
IBS.
That's a pedagogical thing. Meaning that I just thought, well,
That's a what?
pedagogy is
I thought you said something.
but I just make my own
What
thing.
errors are?
I just thought that this is hard to compare to this. I think this is easier to compare and contrast.
Good job.
Much like with cards, right? We always talk about probability of pulling out a card with replacement versus without. So I have a question. If there's a question where you're pulling out multiple cards without replacement, hypergeometric or binomial?
Hypergeometric.
Hyper.
But with replacement?
Binomial.
There you go. And this is important to understand because you're going to be getting questions whereby we don't tell you whether something is hypergeometric or
You're just
binomial.
being mean.
Well, no, but that's just the way it is. Again, if you're a family doctor and I come to you and I'm not feeling well,
Oh, you're gonna tell us what to do.
yeah, am I going to
No,
tell you the doctor what
CT
to
scan tells us which part is wrong.
Oh, God.
And then we change it. But
So you don't need to know anything these days.
no, you need to know how to do each one, but you don't need to diagnose it.
Just
The
Google it.
machine diagnoses it for you. It says that the problem is here, and then you
Fine. Even if you forget how to develop each formula, you need to know which one to use.
no, the reverse. You don't need to know which formula to use, but you need to know the formula.
You need to know how to use each one.
Or you just try every single one and then how do you know which?
No, I'm saying in real life, in surgeries, they say, you know that the problem is this because of the machine, the CT.
But how about if you have to diagnose a problem? Someone says, I don't feel well.
Then you're not a surgeon.
Okay, fine. But don't surgeons.
Then you're changing the whole example, sir.
Fine,
You
you're
said
not a surgeon. You're the specialist.
You have
Who's
cycle.
supposed to diagnose?
Okay, so that now you diagnose that diagnosing is your formula. But the person in the front that sends him to you gives you this is he needs diagnosing. He says use that.